Good morning. Good morning. Harry. Okay. Shall we turn on the videos? Did you get your marks for the second term test? Not the marks. Yes? No? Oh, videos on කරන්න. මොකද එන්නේ නැද්ද පේන්න? Hello, turn on your videos please. Miyuri, Tesini, අද මොකද special දවසක්ද? Are you out of home because of the long weekend? එහෙම එකක්ද? Yes, Kavisha, Tesini, Gavisha, Sheneli, Limansa, Shenela, Adishanang මොකද? Is there a problem? Hari, so we are going to start a new lesson for the third term. Komalan marks hamvicha evanna some of the in this from 6 to 9 the parents send the marks, right? Happily send their marks. And 10 11 එනකොට ටිකක් අඩුයි communication. එහෙම වෙන්න බෑ. Right? You have to communicate properly. Yes, if you have got your marks, please send me to the chat to know your marks. This is a long weekend just after the term tests and school holidays started. Most of you may, some of the students may be out of home in the holiday mode. But we have to start our work today because we are going to have a holiday on the next Saturday, right? Next Saturday, I will not be able to conduct the class. That is why on the 2nd and 9th, we are having the class. සමහර අය ගොඩක් අය දැන් එළිය ඇත්තේ මේ long weekend එකක් නිසා. කමක් නැහැ. හරි. Hydrostatic pressure and its application. So we discussed two biology lessons. Then we are going to start a physics lesson. Okay. Hydrostatic pressure marks සම්බුන් නැද්ද කාටවත්? දුන්නේ නැද්දානේ marks? ගොඩක් වෙලාවට 10 and 11 තිබුණේ close to the holidays නේද? Still you may haven't received. That's true. ඉන්න නැතුව ඇති. Okay, Amadi 86. Very good. And manually you sent me, right? Not manually. Muri you sent me, right? Is it for the second term test? No. You had it. You didn't have your second term test yet, Muri. Samatibu නැද්ද? Hari, okay. Mark සම්බුනම් කියන්න. Maybe after the holidays, right? Hari, so you have learned about pressure in grade 9 also. Matakada. We define the term pressure. That is actually the pressure exerted on solids, right? Pressure equals perpendicular force divided by the area. So here in this grade 10, 15th lesson, specifically we are moving on to the hydrostatic pressure, but as the first part, I have divided the lesson into 3 parts and sent you 3 tudes. So in the first part, actually, we are considering about the solid exerted on, the pressure exerted on solids, right? Pressure exerted on solids. Hari. So we can define the term pressure. Kaur hari define karan. Yes. Define the term pressure, Shenela. as you can remember? Oh, anyone else? Tessiniko, turn on the video. Netumi, Shenali, Kavisha, Gavisha. Yes, how do you define the term pressure? Yes. Force exerted on a unit area. The force exerted on a unit area. Hari. So we'll write pressure is the force. Pressure is the force acting on a unit area. Force acting on a unit area. So we can write the equation. Pressure equals perpendicular force divided by the area, right? Or else we can say P equals F over A, right? Perpendicular force exerted on a unit area. That is the pressure. P equals F over A. And please turn on your videos. Videos on karagena vada karanna one. So according to the equation, what are the units? Force is given by Newton. Area is given in square meters. Therefore, the unit of pressure can be expressed in Nm minus 2. But the SI unit of pressure is what? That is Pascal. Capital P, simple A. And remember, 1 Nm minus 2 is equal to 1 Pascal. 1 Nm minus 2 is equal to 1 Pascal. Hari, as pressure has only what? As pressure has only a, yes, magnitude. It has only a magnitude. It's a 10 Pascal. 15 Nm minus 2 likewise. So since it has only a magnitude, we call it as a scalar quantity, right? It is a scalar quantity. Remember that. It is a scalar quantity. Hari. Now do the calculations. Amadi, you had a last term exam means? Did you? That means are you going to an international school? Ah, okay. So your term begins in September, right? Ah. Okay, Muri. So Shenali, Ranu, Manuti, Kavisha, do the calculations. Hari, have you finished? Kian Balan, the answers. Kavisha, what's your answer for the first one? Kavisha? No response. Havishka? Sorry? Okay, let's see. So it says a large book is kept on a table. The mass of the book is 3 kilograms. The area of the book in contact with the table is 0.06 square meters. Now find the pressure exerted on the table. So here force is the weight, right? Weight of the book exerts the force on the table. So weight is mg, right? Therefore you can say force is, the mass is given as 3 kilograms, 3 into 10. That is 30 Newton. Then you can write the equation pressure equals force divided by the area. So the force is 30 Newton, 30 Newton, and the area is given as 0.06 square meters. So this is like 3000 divided by 6. 3000 divided by 6, that is 500 Nm minus 2 or 500 Pascal. Hands up those who got the answer. Very easy. Balan. Hari. So there you have to have the concept that the force is exerted by the weight of the book. Right. Dimensions of a box which weighs 100 Newton are given below. Find the pressure exerted by the largest surface. So what is the largest surface? 2 into 1. Neither. 2 into 1 area is the largest surface. So pressure equals force divided by the area. Force is the weight 100 Newton. And the largest area is on a largest surface. Largest area equals 2 into 1 square meters. So that is 2 square meters. Therefore, it is 50 Nm minus 2 or 50 Pascal. Okay? Harida. Limansa, give me the answer for part 2. Limansa. Yes, find the pressure exerted by the smallest surface. What is it? Did you get? Janot? 250 Pascal. Let's see. So the smallest area equals, smallest area means 1 into 0.4. Neither. 1 into 0.4 square meters. Right? That is the smallest area. Therefore, pressure equals force divided by the area. Force is 100 Newton. The area is 0.4 square meters. Yes, then according to that, 1000 divided by 4 means 250 Nm minus 2 or 250 Pascal. Did you get? Gatta neda? Then what is the conclusion that you can gain out of this? When the surface area is the highest, the pressure is low. When the surface area is the smallest, the pressure is high. Right? So you know that relationship. In grade 9 we have discussed. When we have broader straps of the shoulder bands, the pressure exerted on our shoulders is less. When the contact area is more, the pressure exerted is less. That is why in heavy vehicles there are more number of tires to reduce the pressure exerted on the ground. When the area is less, the pressure exerted is more. That is why we sharpen the cutting edge of a knife. The tip of a nail is sharpened. When the area is less, it exerts a more pressure. Harine? If another mass of 10 kilogram is kept on the smallest surface is this. What is the pressure exerted? Hari. If another mass of 10 kilogram means total weight. Total weight is equal to, already it had 100 Newton. Another 10 kilograms means another 100 Newton. That means it is altogether 200 Newton. And what is the pressure exerted? I will write somewhere here. Pressure equals force divided by the area. So the force is 200 Newton divided by the smallest area is 0.4 square meters. So this is something like 2000 divided by 4. So what is it? 2000 divided by 4 means 500 Nm minus 2 or 500 Pascal. So බලන්න මේ parts තුනම හරියයි. Hands up those who have got all 3 parts correct. හරි. වැරදුන අයත් ඉන්නවානේ මෙතුජ වැරදුනාද? අදීශ වැරදුන ඒවා හදාගන්න. හරි. I will keep this for another 1 minute since you are making the corrections. You have to concentrate නේද? නැත්නම් වරදින්න හේතුවක් නෑ. You have to concentrate on this. What is the smallest area? What is the largest area? Then you have to substitute for the equation. That's all. And you have to know that when an object is kept on a surface, the weight of the object exerts a pressure. Now, when we are standing like this, our body weight exerts a force on the ground. Right? Harine? Shall I clear the things? Lian on Lian. Hari. We'll move on. Then you can do the third one also. Yes? No, we didn't discuss that yet. I have allowed you to do the third question. Did you all do the third one? What's your answer, Metuja? Yes, Metuja. Hadanada. Gavisha, what's your answer? Kiyanna. It's okay. Yes. Oh, kiyanna any answers. Yes. කියන්න ඔගොල්ලෝ ආන්සර්ස් කියන්න ප්‍රශ්න අහන්න ඒවට මොකුත් හිතන්න එපා ඔගොල්ලෝ කරන ඒ කියන්නේ ඔගොල්ලෝ උන්ට මේක වැරද්දක් වුණොත් ඒකෙන් අනිත් අයත් දෙයක් ඉගෙන ගන්නවා නේද? මෙතන උත්තරේ වැරදුනොත් ඒක ඇයි වැරදුනේ කියලා අනිත් අයටත් කියන්න පුළුවන්. නේ? නිසා මේ වරදින්න here you are there to share your ideas. Okay, Manuti. Akshaya says 1200 Newton. Hari, Ranu says 120 kilograms. Yes, because it asks about the mass of sand, right? Pressure exerted on the ground by a heap of sand is 200 Pascal. Right, here there is a heap of sand, right? It exerts a pressure of 200 Pascal on the ground. The force is the weight of the heap of sand. Right? If sand is spread over an area of 6 square meters, find the mass of sand. So first you write the equation. Always write the equation, right? Always write the equation and substitute, right? P equals F over A. So, then pressure is given as 200 Pascal. 200 Pascal can, if I substitute along with the units, I will say 200 Nm minus 2 equals the force. Force is the weight of force equals weight of sand. Weight of sand. So I will say W, natham I will say mg. This is equal to mg. W is equal to mg. Divided by the area is 6 square meters. ඔන්න මම units එක දැම්මේ ඔයගලන්ට පෙන්නන්න නිසා units දාන්නම ඕනේ කියලා එකක් නැහැ. Units දැම්මහම නිකන් පැටලෙනවා වගේ නම් we'll write without the units, but you have to be aware, right, what you are using. 200 equals mg divided by 6. එතකොට mg equals 1200. මේ 6 into 200. That is 1200. Therefore, m equals 1200 divided by 10. That is 120 kilograms, because you are asked about the mass of sand, not the weight. Right? Therefore, it should be 120 kilograms. Hands up those who got the answer as 120 kilograms. Yes, Netu has sent the answer. Hari. Most of you have taken. Tesini මොකද උනේ? Find the weight. Hari. Enam higher the contact area, the මොකක්ද දෙන්න ඕනේ for the blank. The lower the pressure. Higher the contact area, the lower the pressure. List out the instances where lowering the pressure becomes useful. තනියෙන් ලියන්න for homework, right? Where lowering the pressure becomes useful. මොනවාද? අර මම කිව්වේ having broad straps on the shoulder bags, right? So it is easy for us to carry such a bag. Since the surface area is more, the pressure exerted is less. තව මොනවාද අපි කිව්වේ? lowering the pressure. We need to lower the pressure. එතකොට pressure can be lowered by increasing the surface area or reducing the force. Itin reducing the force is not practical. Therefore, we can increase the surface area. So, the heavy vehicles are having large number of wheels. Several wheels are there because when number of wheels are in contact with the ground, the pressure exerted becomes less. You can note down for homework, you can write. The base of a bridge or the base, the foundation of a building is made broader. That is to reduce the force exerted on the ground. What else? The soldiers who are removing the landmines, bimbo iwat karana soldiers la, they are wearing a special type of a shoe with a broad sole. Patula palala shoe ekak tamai dan. Because if they exert high pressure on the ground, that will blast. Therefore, to exert less pressure on the ground, they are wearing a shoe with a broad sole. Now, what else? Snowboards. Skating නෙමෙයි. Skating නෙමෙයි නේද ඒකට කියන්නේ. Oh. Are snowboards, these are made broader, otherwise they will be buried in snow. When we need to travel on a muddy surface, then we can apply a wooden plank on it. Then we can move easily across it. One is if we apply sand on a muddy surface. We are applying sand on a muddy surface. Then one theory. We are applying a wooden plank on a muddy surface. When we have to cross a muddy surface, we apply a wooden plank. So what's the difference? කියන්නකො කතා කරලා කටහඬවල් අහන්නත් ආසයි. ඔව්. කියන්න. රණු කියන්න. We apply sand on a muddy surface, Ranu. What happens there? Ranu? Denuri? Friction is increased. On a muddy surface, there is less friction. When we apply sand on it, the friction is increased. That means you change the nature of the surface. Nature of the surface is changed. By applying sand, the friction is increased. Therefore, it will not become slippery. When we apply a wooden plank, what happens? Yes. What happens once we have applied a wooden plank on a muddy surface? Yes, Akshaya? Rather than walking on the muddy surface, now you are walking on the wooden plank. What is increased there? Surface area, yes, Manuti. The surface area is changed there. We increase the surface area. Therefore, pressure exerted on the ground is less. Then we will not be buried in mud. We will be buried in mud. Right? Because the sole of the shoe has less surface area. Then it will exert high pressure on the ground. right? But when we are walking along the wooden plank, we have increased the surface area in contact. Therefore, the pressure exerted on the ground is less. You have to apply the scientific theories. Okay? Then for homework, you can write those, right? In grade 9 also we have discussed now. Then number 5, lower the contact area. What happens to the pressure? Lower the contact area, the higher the pressure, higher the pressure. List out the instances where increasing the pressure becomes useful. Yes, what are the instances in which increasing the pressure becomes useful? Yes, Kian Balan. Once again, we can lower the surface area in contact. Just tell me. Yes. So we can we can sharpen the cutting edge of a knife. The surface area is reduced. Then it will exert a high pressure on what we are cutting. Sharpening the cutting edge of a knife. I mentioned another one earlier. Yes. What about a nail? The tip of we don't try to insert the head of the nail to a surface, ne? The head insert karanna to a surface. Don't insert the head of the nail, but we insert the tip of the nail to a surface. Because the tip has a small surface area. The tip has a small surface area, therefore, it exerts high pressure. Exerts high pressure on this. Snow skating, snowboarding and snow skating කියන්නේ දෙකක්. හරිද? අර මොනවාද? ice hockey, skating shoes. Skating shoes. Skating shoes අර හිම මත ලිස්සා යාම කියලා කියන්නේ. Right? These skating shoes, in those skating shoes, the sole is made something like this. So it has a sharp edge. Right? Sharp edge is there. Right? Then what happens? Because of the high pressure exerted on snow, that snow in that place melts and it makes a slippery surface for them to move smoothly. Right? This is snow skating, skating shoes. අර ice hockey එහෙම play කරන අය දාගෙන ඉන්නේ. අර මම ඉස්සෙල්ලා කිව්ව එක snowboarding. අර snowboarding. There the surface area is made high. Therefore, they will exert less pressure. එතකොට හිමේ ගිලෙන්නේ නැතුව යන්න පුළුවන්. Right? Burying in snow is avoided in snowboarding by having a high surface area. Here, these are skating shoes. They apply high pressure by having less surface area. දෙක දෙකක්. Okay. So you can write them for homework, නේද? යන්න පුළුවන් නේ? Then pressure is exerted not only by solids. දැන් අපි කතා කළේ solid pressure නේ. But it is also exerted by liquids and even the gases, fluids. Gaseous pressure is there. Hydrostatic pressure, the pressure exerted by liquids is there. Right? A pressure is exerted on the bottom of a container with a liquid due to the weight of the liquid. අපි බලමු the things related to liquid pressure. Hari. Characteristics of liquid pressure. So you take a shopping bag filled with water. නිවර්දන දවස්වලට එහෙම කරනවා නේ ඔයගොල්ලෝ. Take a shopping bag filled with water, throw it to your friends. Ne? So here what we are doing is we are going to make holes in the shopping bag with water, right? Shopping bag filled with water. You have made holes on it. Then what happens? You can see that water is spread to all the directions. Right? That is because liquid pressure is not only on the bottom of the vessel but also on the walls of it. Not only on the bottom. Liquid pressure is exerted in all the directions. That is one of the characteristics of liquid pressure. Then the pressure at the same level of a liquid is the same in all the directions. So for that, in your laboratory, you may have a plastic bottle with holes made at the same level. එක ළඟ සිදුරු කරපු plastic බෝතලයක් තියෙනවා lab එකේ ඔයාලට පෙන්නන්න. Right? Then you fill this bottle with water. Then you will be able to see that water is spread to similar distances from all the holes. සමාන දුරට විසිරෙන්නේ. It is spread to similar distances. That is because pressure at the same level of a liquid is the same. This is the same level of this liquid. Therefore, the pressure is the same at all these points. We'll say X, Y, Z. So Px, pressure at point X equals pressure at point Y, and it is equal to pressure at point Z because they are at the same level. මේ හිතට ගන්න හොඳට මේවා ඕනේ වෙනවා දැන් ඉස්සරහට. Take these concepts into your mind. If you keep your videos on, you have a better control. Hari. Then pressure in a liquid increases with the depth of the liquid. The pressure at a point in a liquid depends on the height of the liquid column above that point. Then hidana the stock tank at your home. Where is it located, Metuja? Metuja, මොකද නින්දක් දාන්න හිතුවද? Yes. අන්න වීඩියෝ එක on කරගෙන හිටපු ඉඳලා හැරවා ගන්න පුළුවන් වුණා. හරිද? අනිත් අයත් වීඩියෝ on කරලා ඉන්න ඕනේ. ඔයගොල්ලෝ පොඩ්ඩක් out ගිය ගමන් ගන්න ආපහු මේ පැත්තට. Yes, where is the stock tank located? With the stock tank underground or on the roof or at a high elevation. But the stock tank ගෙදර කල්පනා කරනවා එහෙම එකක් තියනවාද කියලා. Yes, where is it? On the roof. Why? ඒ අමාරුවෙන් එච්චර බරක් වහලේ උඩ තියලා තියෙන්නේ. What is the reason? Yes. Could you please repeat, Manuti? To allow the water flow when it is filled. Okay. So if we have kept it at the same level on the ground level, won't the water come out of it? බිම තියන්න නැතුව ඒක උඩකින් තියලා තියෙන්නේ. ඔය තමයි හිතන්න ඕනේ ඒවා. නැත්නම් අර ටෙලි ඩ්‍රාමා එකක් බලලා ඊළඟ දවසේ මොනවා වෙයිද ඒව නෙමෙයි කල්පනා කරන්න ඕනේ. Right? Yes. Why? Why is it kept at a high elevation? It is kept somewhere here. We'll say this is your stock tank. Right? So water is taken out. Here there is a tap. And if it is a storied house, there is the ground floor and the first floor. So what happens? From which tap the water comes out at a high speed, A or B? This is the ground floor, this is the first floor. This is the stock tank. So from which tap water comes out at a high speed? That is A. Then අද්දකම මෙහෙම තියාගන්න වෙනවා. Yes, is it tap A? ඔය ඉතින් A නෙමෙයි නම් B නේ. So water comes out at a high speed from tap B because the perpendicular height is more. Now water is flowing through this pipeline. So when we consider the perpendicular height, it is greater for tap B. අනේ ඉතින් ඒක දන්නවනේ අපි ගෙදරක දැන් stock tank එක වැඩි උසකින් තියනවා නම් water comes at under a high pressure from the taps. හරි ඒක වැඩි උසකින් නැත්නම් හරි හිමීට වතුර එන්නේ. General knowledge. නෙවෙයි common sense. නේද? ඒව දැනගෙන ඉන්න ඕනේ. හරිද? So water comes under a high speed or under a high pressure when the stock tank is kept at a higher elevation. That is because of this reason. Pressure in a liquid increases with the depth of the liquid. දැන් tank එකේ වතුර අඩු වුණා කියලා හිතන්න. දැන් tank එකේ මේ water output එක තියෙන මේ මැදින් නෙමෙයි close to the bottom. මෙන්න මේ හරියෙන් තමයි water output එක තියෙන්නේ. Input is somewhere here. And pipeline එකකින් motor එකක් use කරලා we pump water to that. නැත්නම් නිකම්ම යන්නේ නැහැ නේ වතුර ටික උඩට. Right? So water inlet and the water outlet. Right? So the perpendicular height is more. දැන් හිතන්න tank එකේ වතුර අඩු වුණා කියලා. water cut එකක් දවසක වතුර අඩු වුණා. එතකොට water is coming out at a low pressure. නේද? Because the tank has a less height of water. Therefore the pressure becomes less. ඔන්න අදින් පස්සේ මතක තියාගන්න. එතකොට for this we can have there is a bottle in your laboratory with holes made at different levels. One here, another one here, another one here. A, B and C. හරිද? So when the bottle is filled with water, what happens? Yes. Which one will spread water to the maximum distance? A, B or C? A, yes, because from the free surface of water, the maximum height is therefore point A. Therefore, A will spread water to a greater distance. Then B, somewhat less than that, and C, lowest. Harida? That is because of this. The pressure at a point in a liquid depends on the height of the liquid column above that point. මේ point එකට ඉහළින් තියෙන liquid column එකේ height එක. And we can say PA is greater than PB and it is greater than PC. Right? PA is the highest. PA is the highest. හරිනේ? ලියා ගන්න ඇඳලා. You can draw the bottle, no need to draw that stock tank. ඒක මතක තියාගන්න. ඔගොල්ලෝ මෙන්න මේකට ෆෝත් එකට අඳින්න මෙතන ඉඩ තියාගත්තා නම් හොඳයිනේ. මෙතන we have to build up the equation. හරි. ඊළඟට කියනවා liquid pressure depends. Liquid pressure depends on the vertical height of the liquid column. It does not depend on the shape of the liquid column. It depends only on the vertical height. එතකොට අපි හදමු මෙන්න මේ වගේ container එකක් by connecting different containers. I've made something like this. හිතන්නකො මෙහෙම එකක් හැදුවා කියලා. From the bottom all these are connected. මොනවාද කැමති shape එකක්. එහෙම ගමු. Something like this. So you can see different shapes are there. Once we fill water to this, water will be filled up to the same level since they are connected from the bottom. Since they are connected from the bottom, water will be filled up to the same level. So if I say, MNOP ගත්තොත් letter P comes. This is point R, S, P, U කියලා කියනම. So since these are having the same vertical height, though they have different shapes, the vertical height is the same. Right? The vertical height is the same. Therefore, pressure at point R is equal to pressure at point S, and it is equal to pressure at point T, and it is equal to pressure at point U. So it depends only on the vertical height. The pressure at the same level of a liquid is the same. It does not depend on the shape of the container. Only the vertical height affects. ඔන්න දැන් මේ points 4 හොඳට හිතට ගන්න. හරි. ගන්නකෝ. Then we are going to derive an equation for liquid pressure, right? So this will be the first and the last time that we are deriving the equation, because in the exam you will not be asked to derive the equation. හැබැයි නිකාම equation එක ලියලා දානවට වඩා මේක ආවේ කොහොමද කියලා දැනගන්න එක හොඳයි. Right? For your knowledge. Hari, let's do it. You have finished writing. We have to finish everything by the end of October, right? If the third term test is on November or if it is on December, I don't know, because there is a 1 month holiday for the A-level exam. එතකොට ඒකට කලින් තියන්නත් පුළුවන් term test එක ඉවර වෙලා තියෙන්නත් පුළුවන්. කොහොම හරි by the end of October we will have to finish the theory part. හරිද? එතකොට ඔයගොල්ලෝ ඔයාලගේ වැඩ ටිකත් කරගෙන යන්න ඕනේ. You have to revise and study the things. I have clearly told you in this 2.5 hours it is very ඔයගොල්ලන්ට තේරෙනවානේ there are 20 lessons, we have to cover them up, so we don't have enough time to do enough questions, right? Adequate number of questions cannot be done in this class. That is why we have allocated a separate time. Then from September I asked you to vote. එතකොට වැඩි දෙනෙක් කියලා තිබිච්ච වෙලාව තමයි මට select කරගන්න වෙන්නේ. From September onwards the paper class, theory class time will not be changed, right? Paper class time will be changed to Thursday 7 to 8:30 තමයි වැඩි දෙනෙක් පුළුවන් කියලා තිබුණේ. So please try to get adjusted, right? So until your exams it will be continued. Because of a special reason on Saturdays I will not be able to conduct after 12, right? Enisa. එතකොට ඒක දිගට ආයි වෙනස් කරන්නේ නැහැ until your exam it will be continued, right? එතකොට try to get adjusted. මම කියන්නේ මේ මගේ මම කරන paper class එකට එන්න කියලා කොහොම හරි ඔයගොල්ලෝ you have to do the questions and you have to get the guidance. I'm not boasting about myself. හරිද? මං ගැන කියා ගන්නව නෙවෙයි. ඔයගොල්ලෝ paper marking experience තියෙන, because that is very important. ඔයගොල්ලෝ උත්තර ලියන විදිහ අර 6 to 9 ලිව්ව විදිහ නෙවෙයි. You have to be trained how to write answers according to a marking scheme. හරි, මං කලිනුත් කියලා දෙනවා එක සැරයක් හරි paper marking ගියාම මහා ලොකු experience එකක් ඒක. හරිද? papers සිය ගණනක් හරි ඉස්කෝලේ papers බලනවා වගේ නෙවෙයි. There is a strict schedule there. So we are restricted to a particular marking scheme. ඒකේ විදිහට මොනවා හරි ගැටලුවක් ආවොත් discuss කරලා ඒක කියන්න තේරෙන්නේ නැති ලොකු experience එකක්. එතකොට ඒ experience එක තියෙන කෙනෙක්ගෙන් guidance එක ගන්න. Right? Then එනිසා පුළුවන් විදිහට adjust වෙන්න. If you can't if whatever class you in a class or alone you have to write the answers and get them corrected. හරිද? තනියම හරි වැඩ කරලා answers ලියලා ඒවා correct හරිද කියලා check කරගන්න ඕනේ. හරි නේද? මොකද ඒක අනිවාර්යයි. theory විතරක් දැනගෙන හිටියටත් මදි. සමහර අය දන්නවා ලියා ගන්න විදිහ තේරෙන්නේ නැහැ. So that is essential. Okay, we'll move on. ඊළඟට I will so you know the Viduesa name is mine. So I will conduct here in future I will be restricted to this Viduesa only, right? And online sessions only. So you can have this contact number always, right? No, මේ විදිහට තමයි කරන්නේ. So if anyone wants you have to contact through this number, right? Hari, we are going to derive an equation for hydrostatic pressure or the liquid pressure. Now imagine in this beaker there is water and the height of the water column is given as simple h, and I will say the area of the bottom of the beaker is A, capital A. Then the density of water is given as අපි simple D දාන්න නැතුව අපි මෙතන rho කියලා symbol එකක් ගන්නවා. I think it is a Latin letter. Rho මෙන්න මෙහෙම ලියන්නේ rho. තව මොනවාද ඕනේ? Area is given, height, density, and acceleration due to gravity is given as G. Acceleration due to gravity is G. Hari. So now you know, we learned that a pressure is exerted on not only liquid pressure is exerted not only on the bottom of the container, but it is applied on the walls of the container as well. Now here we are going to calculate the pressure exerted on the bottom. So we can find, you know, density equals mass divided by volume. Mass divided by volume. එහෙනම් එතන අපිට ලියන්න පුළුවන් rho equals m over v. Rho equals m over v. එතකොට volume එක දෙන්නේ කොහොමද? Volume is the surface area into height. එහෙනම් v is equal to a into h. Right? එහෙනම් අපිට මෙතන ලියන්න පුළුවන් the mass is equal to rho into v නේ. Rho into v. එනිසා I will write the mass is equal to AH. On instead of V, I wrote AH rho. AH rho is the mass. Hari. ඊළඟට the pressure exerted on the bottom. Pressure equals force divided by the area. Hari. එතකොට force is the weight divided by the area. And we know weight is equal to mg. Weight is equal to mg. හරිද? එතකොට pressure is equal to mg divided by a. Then instead of m, I will write this. I will substitute this instead of m. P equals ah rho. Then here there is g divided by a. Therefore, we get the hydrostatic pressure, liquid pressure is equal to h rho g. So, ඔයගොල්ලන්ට මේක derive කරන්න එන්නේ නැහැ. You have to use this equation and do the calculations. That's all. Right? Then I will mention the units. Height should be taken in meters. Density in kilograms per cubic meter, which is the SI unit. And G is taken in ms minus 2. Then you will get the unit of pressure in Pascal or Nm minus 2. Harine? Now this is how we obtain the equation for liquid pressure. P equals h rho g. Height should be taken in meters. Density in kilograms per cubic meter. G by ms minus 2. Then you will obtain the pressure in Pascal. Finished? Harine? Shall I clear the things? Where did again? Mentuja tam liyanawada? Hari. Then we have to do calculations. Before the calculation you are given, bunt of a tank is made broader to the bottom. What is the reason? Then why the bunt of a tank is made broader? Tank කියලා කියන්නේ මෙතන වැවක් කියන එක, not the fish tank or any other water tank. It's made something like this, made broader at the bottom. Why? And then this is given for your test. So how do you answer? Yes. කියන්න. හරියන්න හරි වර්ධින්න හරි කියන්න එතුමි. Yes නෙතුමි. grade 7 විතර ඉඳන් එන කට්ටිය ඉන්නවා. ඒ කාලේ නම් අර කුරුල් පැටව් ටිකක් වගේ කතා කරනවා දැන්. නේද තෙසිනි? දැන් ඉතින් කටහඬ අහගන්න ගෙදරට එන්න වෙනවා මට. Yes. කියන්න. දෙනුරි. ඒ කාලේ නම් කතා කළානේ. Yes. නෙතුමි කියන්න as you feel. Yes. So only 2 sentences. Any volunteer, Shanela? To withstand the pressure of the water. Ita kalin you better to say the liquid pressure increases with the increasing depth. In order to withstand or to tolerate that increasing pressure, the bunt of the tank is made broader at the bottom. Right? That's what you have to say. අන්න එහෙම පැහැදිලි වෙන්න කියන්න ඕනේ. Okay? හරි. මේ ලියන්න points දෙකයි. මොනවාද? Liquid pressure increases. Liquid pressure increases. With the increasing depth. With the increasing depth. Liquid pressure increases with the increasing depth. Then you can say to tolerate or to withstand that pressure, to withstand that pressure, the bottom of the tank bunt, is made broader, is made broader. Is made broader. Hari. Then you can do the calculations. 7, 8, 9, 10. Seven, 8, 9, 10 විතරක් කරන්නකො 11 we will discuss later. Can you see? I am doing among a power cut, right? Finished? කළාද? Videos on කරන්න. බලමු. The depth of a certain point in a lake is 2.5 meters. Find the pressure exerted by water at the bottom of the lake at this location. So you have to write the equation and substitute. That's all. P equals H rho G. Right? The height is given as 2.5 meters. Density of water is given as 1000 kilograms per cubic meter. G is given as 10 ms minus 2. So pressure equals 2.5 into 10 is 25. 25,000 Pascal. Or you can write this as 25 kilopascal by dividing it by 1000. 25 kilopascal. You got the answer, right? It's easy. Adisha? Hari neda? Right. Then number 8. The pressure exerted on the seabed at a certain point at a particular location is 105 kilopascal. If the density of seawater is, it is higher than normal water, 1050 kilograms per cubic meter. Find the depth of the sea at that location. So what's your answer? We'll ask from Tessini. Yes, Tessini, what's your answer? What is the height? Why? So once you substitute for the equation, you will get the answer, no? Gavishakin ahua kalina. Generally, 10 meters. Okay, let's see. 1 meter. Right, Balam P equals H rho G. So the pressure is given as 105 kilopascal. 105 into 1000 Pascal. 10 to the power 3. On the kilopascal, I wrote it like this in Pascal. The height you have to find the depth. The density of water is given as 1050 kilograms per cubic meter and G is 10. So you have to find the value of H. So here 0, 0, 105 into 1 and another 0 here. So H equals 10. H equals 10 meters. Hands up those who got the answer as 10 meters. Hands up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Harry. Okay, 13 of you have got the answer. Harry. Varadunalam balannai varadune kiyala. You have to just substitute for the equation. එතකොට 1 kilopascal අර kilogram වගේ තමයි. 1 kilopascal is equal to 1000 pascal. Right? ඊළඟට අපි කිව්වා 1 pascal is equal to 1 nm minus 2. Pascal is the SI unit of measuring pressure. You can remember those. Hari. Then you are given an MCQ. Balan, what is mentioned in the MCQ? The factor that does not affect the pressure of a liquid at a given point is. The factor that does not affect the pressure of a liquid at a given point is. What is it, Sasandi? Yes, density of the liquid affects, acceleration due to gravity affects, depth to the point from liquid surface affects, but not the volume of the liquid. Not the volume of the liquid. That is the second answer. Hari. Number 10. Pressure exerted on a point which is 2 meters below from the free surface of water in a reservoir is. Yes, what's the answer? Adisha, what's your answer? 20,000 nm minus 2. nm minus 2, right? Hari, P equals h rho g. So height is 2 meters, density is 1000, g is 10. So it is 20,000 nm minus 2, 20,000 Pascal. Right, that is the fourth answer. Harine, what is it, Shanali? 2 meters below from the free surface in a reservoir. So this is the reservoir. So this is the free surface. අපි දැන් කිව්වේ හැමතිස්සෙම depth කියලා. H is the depth. Depth කියලා කියන්නේ depth is measured from the free surface. So this point X is located 2 meters below from the free surface. So that is its depth. 2 meters below from the free surface of the reservoir. That is the depth. Harine? So always we are measuring the depth from the free surface. Free surface again then api ගැඹුර මනින්නේ. Now here this is the depth to the bottom. Okay. හරි. ඊළඟ එක කරමු බලන්න. ටිකක් කල්පනා කරලා කරන්න ඕනේ. Very lazy. Find the pressure exerted by a mercury column of 10 centimeters. If the density of the mercury is 13,600 kilograms. ඒකේ kilograms per cubic meter. ඒක එච්චර කල්පනා කරන්න දෙයක් නැහැ. අමාරු නෑ. Do 11 and 12 both. Yes, hari balamu mata kiyanna Raika, what's your answer for number 11? Raika. Raika. Here. Videos on karaganna හැමෝම. Yuri and Manuti told that they have issues with their connection. The others, Penela, Avishka, Ranu, Yenuka, Raika, Kavisha. Hari. Raika, we can't hear. Yes, Chenela, what's your answer? For 11th? She says 136,000. Then Methuja says 13,600 Pascal. Akshaya 25,000 Pascal for the next one, I think. Yeah, I don't know. Sheneli says 1360 Pascal. Muri says 13.6 kilopascal. Somewhat related answers. Netumi says 136 kilopascals. Hari, අර 136 කියන numbers තුන ඇවිල්ලා තියෙනවා හැමෝටම හැබැයි මෙහා වෙලා තියෙනවා. I don't know what is the correct answer. We'll see. Pressure exerted by a mercury column of 10 centimeters if the density of mercury is 13,600 kilograms per cubic meter. P equals H rho G. So H is 10 centimeters means 10 divided by 100 meters when known. Okay, තමයි වෙනස වෙන්නේ නැත්තේ. You have to substitute in meters. Here 13,600 kilograms per cubic meter and this is 10. Therefore, it is the pressure equals 136 into 10 to the power 2. Again, 13,600 Pascal. If it is in kilopascal, if it is 13.6 kilopascal. So, balan me answer kaapu aya. Yes, 13,600 Pascal. Hari, most of you have taken. Good. Then, balan decimal se ha meha vela neda samahara age. A tank with a length 4 meters, width 3 meters and depth 2 meters is filled with a liquid of density 600 kilograms per cubic meter. What is the pressure exerted at the bottom of the tank due to the liquid? Hari. Bottom of the tank due to the liquid. Hari. So, what is the area of the bottom of the tank? Length is 4 meters. Width is 3 meters. Length and the width are applicable for the bottom. So, but that is the surface area and here we are not considering weight of the liquid. We are considering surface area එක දීලා weight of the liquid is this කියලා කිව්වා නම් P equals F over A දාන්න තිබුණා. දැන් එහෙම නෙවෙයි. The depth is 2 meters and density is given. එහෙනම් අපි මේ විදිහට හදන්න ඕනේ. Right? P equals H rho G should be taken. Hari. So the height is 2 meters. Density is 600 kilograms per cubic meter into 10. So 2 into 6 is 12. 12,000 Pascal නැත්නම් 12 kilopascal කියලා කියන්න පුළුවන්. 12,000 Pascal. Oh, that is equal to 12 kilopascal. Simple K, right? 12 kilopascal. Pressure exerted at the bottom of the tank. What is the force acting on the bottom of the tank due to that pressure? What is the force acting on the bottom of the tank? Yes, what's your answer? Ranu, what is the force acting on the bottom of the tank due to that pressure? Yes, Ranu? Not sure. Why? Why aren't you sure? Chenelli says 144,000 Newton. Janot? Muri says the same answer. Okay. We'll see. එතකොට මොකද්ද වෙන්න ඕනේ? Force. මේ pressure equals force divided by the area. දැන් ඒක තමයි මම අර equation එක derive කරලා පෙන්නුවේ. The weight of the liquid exerts a pressure on the bottom, right? So pressure equals force divided by the area. So we are asked to calculate the force. Therefore, force equals pressure into area. Pressure into area. So the pressure we have calculated 12,000 Nm minus 2. And what is the area? Area of the bottom. Length is 4 meters. Width is 3 meters. That is 12 square meters. හරිද? එතකොට force equals here 12 square meters. Per square meter, square meter. 12 into 12 is 144. 144,000 Newton. 144,000 Newton. Hands up those who got the answer. 144,000 Newton. Okay. Yes, Chaneli. නෑ කිලෝ පැස්කල් වලින් සබ්ස්ටිටියුට් කරන්න බෑනේ. එතකොට මෙතන කිලෝ වෙනුවට we have to write 10 to the power 3. හරිද? 1 pascal is equal to 1 nm minus 2 no. Therefore, when you are substituting, here you have to write 12 into 10 to the power 3 nm minus 2. හරි කිලෝ පැස්කල් වලින් සබ්ස්ටිටියුට් කරන්න බෑ. හරිනේ? ඔන්න පොඩ්ඩක් කල්පනා කරන්න ඕනේ දැන් හැමෝම. දැන් ආන්සර් එක ගත්තා හොඳයි. ඒක විදිහට වෙනස් වෙනකොට හිතන්න ඕනේ. එකම විදිහට දෙන්නේ නැහැ මේක මෙහෙමම ලිව්වා සබ්ස්ටිටියුට් කළා ආන්සර් එක ගන්න නෙවෙයි. The questions come in different forms. මහන්සිද දැන්? තව එකයි නේ මේක විතරයිනේ මේ ටියුට් එකේ තියෙන්නේ. ඊපස්සේ පොඩි බ්‍රේක් එකක් ගමු නේ. Finished. හරි 13 කළාද ඔයාලා? නෑ නේද? Have you done number 13? අපි මෙහෙමම කරමු. Consider the following instances P, Q, R and S are. දීලා නෑනේ diagram එක. P, Q, R and S are 4 points at the bottom of each vessel. Which point will experience the highest pressure due to the liquid if same liquid is filled into all vessels? Hari, ඔන්න මම ගන්නවා diagrams ටිකක්. This is point P. Yes, what's the answer? Yes. Which experience the highest pressure due to the liquid? If the same liquid is filled. Yes, Chenelli says P. Yes, you all say yes, P, because it contains the highest highest depth, right? This perpendicular height of the liquid column is highest in this one, right? Rather than this. You learned that only the perpendicular height affects. Therefore, this experience the highest pressure. Hari, before we move on to the next part, then පොඩක් ගිහිල්ලා break එකක් අරගෙන එන්න. විනාඩි 2 3 minutes, right? Drink some water and come back. Yes, did you come back? Harine? Have you returned after the break? Hari.
Today we shall learn more about pressure. Let's take plastic bottle and make holes all around near the bottom at same height. We make all the holes at the same level. Now seal the bottle. Look, water is coming out of all the holes, not just water is coming out because of the pressure, which means water is exerting pressure on the walls of the container. Notice water is coming out of all the holes all at the same distance bottle. What does it mean? This means water pressure is equal in all the directions depth. Now let's take another bottle of example. water falling from the hole which is near the top is the shortest distance water, and water coming out of the hole near the base is falling at greater distance water. What do you learn from this? Water comes out of the bottle because of pressure. Water coming out of the hole nearest to the base goes farthest. So this means water pressure increases with depth, meaning water pressure increases with the height of water column, which is exerting the force. These two experiments, we can say water exerts equal pressure in all the directions at equal depth, and water pressure increases as we go deeper, or we can say water pressure with the increase in height of water column. Let us try down on what is by it. You will find that the force pushing it upward against your force. Water is applying upward pressure wall. So we saw water can apply downward, upward pressure, and neutral pressure in sides as well. So we can say water or any liquid apply pressure in all the directions. Sum up what we learned today. Liquids exert pressure in all the directions. Liquids exert equal pressure at the same depth. Lastly, pressure exerted by the liquid increases with the increase in the height of its column. It increases with the depth. That's all for now. Bye bye, children.
Okay. Then we will get an introduction to the transmission of liquid pressure, right? Transmission of liquid pressure. Hari. So now you know once we apply a pressure on a gas, the balloon is filled with air. So we compress the balloon, and you know that it can be compressed up to a certain extent. If it cannot withstand the pressure, it will blast. But in the case of liquids, can we apply a pressure on them and compress them? Okay, compression means we can reduce the volume. Can we do that by applying a pressure on a liquid? That's not possible. Right? Liquids do not get compressed by forces exerted on them. The pressure exerted at one point in a liquid can be transmitted to another point in the liquid, right? Liquids cannot be compressed due to the application of a pressure. That pressure can be transmitted from one place to another, right? That is what we call as the transmission of liquid pressure. So there are certain applications of this principle. So you may have seen the vehicle hoists which are at the service stations. අර කායක නැත්නම් මොකක් හරි vehicle එක උඩට උස්සන්නේ, right? That is lift up to a certain height. That is known as the vehicle hoist. In that vehicle hoist also we make use of this theory, transmission of liquid pressure. Hari. Here you are given the setup, a hydraulic press. So here there are two arms. One is having a less area of cross section. The other arm, it is having a high area of cross section, and these arms are connected from the bottom. And the same liquid is filled inside, that is oil, right? Hari. We'll say here here the pressure, the force is exerted on the smaller arm by piston A, right? Then that force, the pressure is taken out. The output is given by piston B. Is having a high area of cross section, right? High area of cross section. Hari. Now I will give values for the pressure and the, values for force and the area. Okay, we'll say we are the area, surface area of piston A is 20 square centimeters. 20 square centimeters. Then a force of 40 Newton. 40 Newton is exerted on the smaller arm, the small piston, right? And I will say that the area of the large piston, the area of cross section of the large piston is 400 square centimeters. 400 square centimeters. So you have to find out what is the force output. Force output which is given by the large piston here. What is the force output? හොයන්න බලන්න. කොහොමද හොයන්නේ? First of all, you have to find pressure. Pressure at piston A. You have to find the pressure there. What is the theory? The pressure exerted here is also exerted on this particular point. Why? They are the same level of the same liquid. The pressure exerted is transmitted and the force output is given there. ඔයන්නක බලන්න ඉස්සෙල්ලා the pressure at piston A. What is it? What is it, Janoth? So the videos on කරගන්න කට්ටිය තව පොඩි වෙලාවයි තියෙන්නේ. Turn on your videos and do the work. Yes, Janoth, what is the pressure at point A? Janoth. 800 Pascal. Hari, Medana, you can just convert the units. I have given it in square centimeters. You can convert it into square meters. Hari, එහෙම හොයන්නත් පුළුවන්. නැත්තම් කොහොමද square centimeters square meters වලට convert කරන්නේ? Yes, 20 square centimeters means how many square meters? Yes, how to do that? A centi stands for 10 to the power minus 2, right? එතකොට 20 square centimeters කියන්නේ 20 into 10 to the power minus 4 square meters. හරිද? ඒ කියන්නේ square centimeter කියන්නේ centimeter into centimeter no? Centimeter into centimeter. So in order to convert centimeters into meters, we have to divide by 100. Again, we have to divide this by 100 two times. 100 into 100. So that is 10 to the power 4. Dividing by 10 to the power 4 means minus 10 to the power minus 4 කියන එක. එහෙම නැත්නම් you can just keep the value in NCM minus 2. එහෙම තියන්නත් පුළුවන්. Force is 40 Newton. 40 Newton divided by the area 20 square centimeters. Make I will keep it like that. Right? ඊට පස්සේ the same, you have to say the same pressure is transmitted along the liquid and the same pressure is exerted on the large piston. Right? This pressure is transmitted along the liquid and the same pressure is exerted on the large piston. Large piston. And you have to find the force given out by the large piston. එහෙම නැත්නම් the weight that can be held by the large piston. මේ අපි මෙතනින් පොඩි force එකක් දෙනවා. Because of the output, we can hold a higher weight at large piston. And you can have to find out the force output at the large piston. හොයන්න බලන්න. Force output at the large piston. Find the value. Done? Here once again we know that the same pressure is exerted there. No? So I will write P equals F over A. Hari. එතකොට what is the pressure at the large piston? The same pressure. So I substitute it here. 40 Newton divided by 20 square centimeters. And I substitute the same thing. Then the force output we have to find. The area is given as 400 square centimeters. Then nama square centimeters වලින් තියෙන නිසා තමයි I didn't convert the value into square meters here. Here square centimeters. Then 20 into 2. එතකොට F equals here 2 into 400. That is 800 Newton. 800 Newton. බලන්න මොකද වෙලා තියෙන්නේ කියලා. When we apply a force of 40 Newton on the small piston, the large piston gives out a force of 800 Newton because of the transmission of liquid pressure. හරිද? So once we on applying a smaller pressure force on the small piston, a large force output can be taken from the large piston. So that is what we make use in the vehicle hoist as well. So in the vehicle hoist, the vehicle is very heavy. Maybe normally a car 5000 Newton. Likewise, and so on the small piston we apply a smaller force. As a result, we are able to lift a large weight because of using of this transmission of liquid pressure. Right, application vehicle hoist used in service stations. Pahadilida, if you have any problem, just ask, right? Get it clarified. Hari, shall we have a look at the vehicle hoist then? You have finished. So our target is to finish the things by the end of November, not November, October, right? By the mid of October, we'll try. Grade 11 lessons before the O levels, we have to do questions as much as possible. Now I'm going to clear the thing. Vehicle hoist used in service stations. A smaller force is exerted on the small piston. The small piston moves a greater distance, and due to the transmission of liquid pressure, the large piston gives a large force output as a result, and it moves a less distance. The large piston moves a less distance and it is able to lift a larger weight. Hari, api liyamu a description on the other side. I will write like this. Here the liquid inside is an oil. Oil has a less density than water. Liquid means here you can say oil. Hari. The force is multiplied due to the difference in the surface area, right? To say moved, right, rather than traveled. So the same theory is made used in the hydraulic jack, which is used to lift one side of a vehicle to remove the wheel. Hydraulic jack. In order to remove the wheel, we need to lift one side of the vehicle. For that, we apply a smaller force on the handle, and that is multiplied and given out on the vehicle as the force output due to transmission of liquid pressure. Finished? හරි නේද? Okay. So the hydraulic jack is given. Have you finished writing? Okay. So the hydraulic jack is shown here. So here this is the handle. So once you apply a smaller force on the handle, smaller comparatively small. So here there is a small piston and the pressure is transmitted through the liquid. Then here there is a large piston. The large piston gives a greater output. This is known as the hydraulic jack. Hari. Then මෙහෙම ලියන්න. Hydraulic jack is used to lift one side of the vehicle, to remove a wheel. Yes, a hydraulic jack is used to lift one side of a vehicle to remove a wheel, right? To remove a wheel. A force is applied on the small piston. A force is applied on the small piston. The pressure caused is transmitted to the large piston, is transmitted to the large piston through the oil, through the oil, giving a large force output, large force output allowing to lift the vehicle, allowing to lift the vehicle. Allowing to lift the vehicle. Hari. Then the next application is the hydraulic brake system of a vehicle. විනාඩි 5ක් ඉන්න පුළුවන් නම් I can finish that part also and finish today's lesson. Hydraulic brake system of a vehicle. So in that case, we apply a force on the brake pedal. We apply a force on the brake pedal. Right? We apply a normal force on the brake pedal. So අපි brake oil කියලා දානවනේ නේද? So that the pressure exerted is transmitted along this brake oil. Here close to this, there is a small piston in the master cylinder. Small piston is there. So a force is applied on it. Then the pressure exerted is transmitted along the brake fluid. And close to the wheel, there is the slave cylinder with a piston with large area of cross section. Therefore, a greater force is applied here. Now, here close to the wheel, then hitannako, this is the wheel කියලා. Right? This is the wheel. So, on either side, so this is the part which rotates. Right? On either side, the brake pads are there. මොකද වෙන්නේ දැන් due to the pressure exerted, the brake pads just hit the rotating part of the wheel. දෙපැත්තෙන් හිර වෙනවා and then the wheel cannot rotate further. Therefore, the vehicle is stopped. In some of the vehicles, this is applied on all the four wheels. Are four-wheeled vehicles කියලා in some, most of the ones only on the front wheels, right? But the smaller force applied on the brake pedal is transmitted as a greater pressure, as the pressure is transmitted and it is given out as a high force. Force output is greater. As a result, the rotating of the wheels is stopped. When the driver applies a force on the brake pedal, it is transmitted to the piston in the master cylinder. The force exerts a pressure in the oil inside the cylinder. This pressure is then transmitted through the oil to the slave cylinder near the wheel. Here the slave cylinder near the wheel. The brake pads connected to the slave cylinder are pressed to apply a pressure on the brake discs or the brake drums. They can't rotate. As a result, the rotation of the wheels is stopped. The brake pads connected to the slave cylinder are pressed to apply a pressure on the brake discs or brake drums. Here it says area of cross section of the slave cylinder is greater or smaller than the area of the cross section of master cylinder. Yes? Greater or smaller? කියන්නකෝ. area of cross section of the slave cylinder is greater than the area of cross section of the master cylinder. Therefore, force applied on the brake pads is greater than the force applied by the driver. Then driver when on driver on the brake pedal. Driver ලොකු force එකක් දෙන්නේ නෑනේ. He applies a normal force on the brake pedal is multiplied and given out on the brake pads. Therefore, the rotation of the wheel is stopped. හරිද? එතකොට මේ කතා කළේ vehicle hoist, hydraulic jack, hydraulic brake system of a vehicle. All these are applications of transmission of liquid pressure. Right? හරි. දැන් ඔය ටික හොඳට බලා ගන්න. Next week we are not having the class. For both theory and paper students, I will share a set of questions to be done on that day, right? We have to start with the gaseous pressure next time. Gaseous pressure ivarunama, we have to move on to the law of flotation, right? The Archimedes principle and all this. So, most probably on 23rd, we will be able to finish this lesson. Okay then. See you on the 23rd then. Enjoy your holidays. At the same time, just revise the previous lessons as well. I will send you some homework for the coming week, right? And see you on the 23rd. Stay safe, and we are having the paper class at 12:30, right? Okay, stay safe and have a nice day.